in this video we have to learn that what are functions, what is the definition of function. So let's start. Functions are kind of a machine. So assume that this is our machine, and this machine takes some inputs. We usually call our input as x and produces some corresponding outputs. We call our output y. So it takes an input x and produces output y. So maybe I should draw an arrow here, means that this is input, and maybe I should draw an arrow here saying that this is output. So, but there is one key condition. Condition is that for every input there must be a unique output. So let's write, to understand this, let's write a set of all inputs for a function in this diagram. So these are possible all inputs for our function. And let's draw a set of all outputs for our function for these inputs. So these are set of all outputs. So set of all the inputs are called domain. So we call this set as domain, and set of all output is called range. So we call this set range. So if this is a valid function, then for every input we can have only one output. So for this input we have this output, for this input we have this output, and maybe for this input we also have this output. This is allowed because for every input there must be one output, but two inputs can have one output also. That is fine. So for this input we also have a unique output. So for every input we have a unique output. So this is a valid function diagram. But in other case, if we have some equation where for one input there are 2 or 3 outputs, then and maybe for other input we have one output, but this is not a valid diagram for function because this input has 3 possible outputs, and this is not a function, and this is a function. So let's see how we write function mathematically. Yes?
Is it not like a is it like, for example, that was like not a function, or is it like an incorrect function?
This is not a function.
Not a function totally.
Yeah, this is not a function totally. Yeah. So now let's write some functions mathematically. Usually we write function mathematically as this, that we say f(x) is equals to x square. This is a mathematical representation of a function where we are saying that this is basically the function name. This is the name of our function. Our name of the function is f, right? And we are saying that this will be the input of our function. This is input of our function, and this here will be output of our function, right? This here will be the output of our function. Make sense? So this is our name, this is our input, and this is our output. Now, yes?
Is the name always necessary?
So name is not always necessary. Basically, sometimes we can write this function like this. We say y is equals to x square. So we're saying that output is equals to x square. Sometimes we write function this way also, right? But this way is more commonly used, but we can write function without name. In this case, we have not used the name. We're saying this output is equals to this, basically, right? So for this function, we can, let's say, if we have designed this function ourselves, then we can say that this function will take these set of input, or we can say this function can take any input, as long as that input is valid. That input has to be valid. In this case, we can say this function takes all possible real numbers as inputs. So we say that x is this sign is belongs to or members of or in. So this is like belongs to, member of or in. Since we say x is in R. That means x is all real numbers, right? Then now we can say y is also all R. Y can also be all real numbers, but it's possible. So in this case, but the actual y will be the subset of this, because all numbers might not be generated using scares, right?
What's subset?
Subset means like you have a bigger set and you have some part of that set. It's a subset, right? We will make some lectures also about the set theory. So y is not a range, because the actual value that the function will get will be the range. In this case, y is our codomain. So there is basically domain, there is a range. Range are the actual values that the function produce, right? But if we have the bigger set, if we have a superset of the range, we call it codomain, right? So in this case, y is codomain, right? Because y has maybe more dots here, which we will never able to get. Make sense? So usually domain and range are enough. So actual values might be subset of this codomain. Yes?
How can we not get all real values by squaring?
So y is equals to -1 cannot be, we cannot get y is equals to -1 with scaling any real number, right? So a scale of any real number is not -1, for example. So that's why our range is subset of this codomain. So now let's write some values. Let's write some values to understand this, right? So let's write a small table here. So here are my inputs and here are my corresponding outputs, which are equals to x square. So y is equal to x square is here. So if my input is 1, what will be my output for this function?
1.
1. If my input is 2, what will be the output of this function?
4.
4. Very good. So you understand the concept of function. If my input is 3, what will be the output?
9.
9, right? So if my input is 4, what will be the output?
16.
16, and so on, right? So if my input is -1, let's say -1, what will be output? -1 square is, because minus will be plus, so it will be +1. So once again output is 1. So this is a valid function, right, or not? Because for two different inputs, it is producing same output, and this is allowed. Two different inputs, same output is totally allowed. But what is not allowed, that for every input there must be a unique output, otherwise it is not a function. Make sense? So now let's clear the board and see that if we have a graph, how can we say that if this graph represents a valid function or not? So we can draw a graph of any equation, like this is also an equation, like y is equals to x square is an equation, by putting different values of x's, put different inputs to that equation. But every equation doesn't represent a function. So let's say how we can make a graph. For example, for this data, we can make a graph by putting our x values on the x-axis and our corresponding outputs on the y-axis, and then making a graph. Like for example, if my x was 1, then my y was also 1, so this point will be here. If when my x was 2, this was 1, and when my x was 2, my y was 4, so it will be 1, 2, 3 and 4, so that means my point will be here, right? And when my x was 3, then my y was 9, so 4, 5, 6, 7, 5, 6, 7, 8, 9, somewhere here, so this is here. So then I can make a graph, maybe like so, especially so something like this, right? So my graph will goes like that. Make sense? So let's say you have a graph, and this graph is for some equation. So if this graph is for some equation, and you want to see that if equation represents a valid function or not. So what you can do, you can take any point on the x-axis, and you can draw a vertical line, a very straight line. Vertical line is the line which is parallel to y-axis. So a line which is parallel to y-axis. And if such a line that intersect our graph at two different points or more than one point. That means for a same value of x, you have multiple values of y. That means for a same input, you have multiple outputs. That means that graph that you have made does not represent a function. So for in this case, if I maybe make a line here or here, this line will always intersect with our graph at only a single point. So this graph represents a valid function. But let's say I have a graph like this, right? And then I make a vertical line here. Vertical line is a line which is parallel to y-axis, so I make a vertical line here. Then this vertical line intersects this graph at two different points, right? So that means this basically graph or this curve, maybe curve is a better word, this curve doesn't represent a valid function, because for this value of x, let's say x is equals to 7, we have two different corresponding y values. So this is not a function, this is a function. So let's continue and understand some of the properties of function. So stay tuned.